Hi everyone, in this video we're going to be looking at the lecture guide for Module 2. So in this video I'm going to go through some of the beginning of this lecture guide and just discuss what this module is about, and specifically in terms of what we've done previously and what we're doing now. So this module is all about trying to put some terms or terminology on ideas that we've already done. So specifically, to start out, this idea of being statistically significant. So right here, statistically significant. This is something we've already seen. I'll show you an example in just a second, but we've already seen this idea. I'm just going to give a name to it. The second one, the null hypothesis and alternative hypothesis, we have actually already seen this idea, done a ton of examples with it. We're just going to give names to it. So these first two major ideas we've already seen for 2 weeks. We're just going to put names on them now. All right. We've also already done some simulation, so we're going to continue to do that. And then we're going to be using all of these new terms that really, remember, represent stuff we've already done in this idea of hypothesis testing. So hypothesis testing, we've already done that. We're just going to put a name on it now. So what you need to do with this module, I know there's a bunch of new words and some of them are big and they're just look like they're thrown together, but really all we're doing is we're just saying we've done an idea for 2 straight weeks that you're getting more comfortable with. I'm going to put a specific name on it now. That's it. So let's get started. Statistical significance right here. Okay. So given a set of assumptions, assuming we've already done that a bunch, right? We assume the die is fair. We assume that Yummies is getting 1/3 of all the candy purchases. So we've already done that, assuming. So given a set of assumptions, an event is statistically significant if it is unlikely to occur just by random chance. Okay, so let's think about what we've already done so far. We've tried to answer a problem by making an assumption about what's going to happen, creating a chance model, and then looking at our data and saying, does that fit? This is exactly that. This is exactly what we've already done. You are statistically significant, not you, but something is statistically significant if, when we do what we've already done, we build a chance model, we take our data, we look at it and go, does this fit? If what you've already done, your answer is no, this doesn't fit, we just call that statistically significant. So another way to say this, under the chance model, so I'm looking at this line right here, under the chance model, these pictures we've created, if our actual observed statistic, so the number we got from actually digging in, grabbing data, if that is unusually high, so data points over here that we've been trying to point out, or unusually low, so again data points over here outside the pattern, we call that statistically significant. That's your idea of statistically significant. So as an example, remember from the last module we were doing Yummies candy bars. So we were asking the question, well, is Yummies kind of just the same as the others? Are people just randomly picking which candy bar to get out of the 3? Or does Yummies seem to have better than just the 1/3 of all of the purchases? Do people seem to prefer Yummies more? That was our question, right? And so what we did, if you remember that example, go back if you don't, is we said, okay, assume that Yummies is really just getting 1/3 of the purchases. Create a chance model. So that's what we did. And remember, we were basing this off of a week of 10,000 purchases. So just to remember that. So we had, hey computer, resimulate or simulate the 10,000 purchases over and over and over again, assuming Yummies really only gets 1/3 of the purchases. Okay, we got this picture. And then what did we do? We said, okay, well, this is nice. This is the chance model, assuming Yummies is only getting 1/3 of the purchases. Let's take our data, and if you remember, our data was 40%. So let me put that down here. 40% was our statistic. Okay, so then what did we do? We took our statistic of 40% and we looked at this picture and said, does it fit the pattern? or is it not fitting the pattern? That was what we were talking about. Is it usual, unusual? And what we decided was 40% is way over here somewhere. It is unusually high in this case. So what we would say is that this is statistically significant. Under the chance model, our data doesn't seem to fit. There you go. So we've already done this idea a bunch of times. We're just, if we get that something weird's going on, we're going to say it's statistically significant. Okay. So we have a strategy now. And what this is doing is just trying to put together the idea that should always be in your head about how to attack a problem using statistics. What are we going to do? The 3S strategy. We're going to get a statistic. So we've got some sample. We get a statistic from it. All right, it's a proportion, it's a mean right now. What do? We figure out the by chance alone. So we figure out the chance model, and we've been kind of just breezing past this a little bit. We haven't talked too much about how to create this yet, but we'll get into it more. But the examples of this have been Yummies only gets 33% of the sales. My die will roll a 5 1/6 of the time. My coin will flip heads 1/2 the time. All of these are examples of the by chance. Well, it's just chance. There's nothing interesting going on here, really. It's a fair die, it's a fair coin. Yummies is getting equal share, nothing interesting, okay? So then we figure that out and we make the chance model. So remember, the chance model is right here that we've created. Then what we do is this thing we've already been doing, but we've been a little, not specific about this. I've been just kind of saying, well, look at it, without telling you exactly what to use. Well, that's this third part that we're going to dig into a little bit more in the next few sections, this idea of strength of evidence. So the strength of evidence is us saying, okay, take your 40%. Where is it on this picture? The strength of evidence is a way to measure how strong your evidence is against the chance model. So a couple things that maybe, you're kind of feeling already. 40% should be very strong. Why? Because it's really far away from the pattern. If I got 35%, well, that still kind of looks like it doesn't fit the pattern, really. It's still pretty high, but it's not quite as high. So what we're going to do soon is talk about how do I actually put a number on this idea? Because clearly, if Yummies had gotten in the last week 70%, then that would be much stronger evidence than if they had only gotten 40% or 35%. So that's this piece that we're going to dig into a little bit more in the next section or two. So this is the 3 S's. Get a statistic, figure out a chance model and simulate, get a nice picture here, compare your data to the chance model to find out, do you have strong evidence, do you have weak evidence, do you have basically no evidence against the model. So that's a key point, against the model. Okay. So the other main thing here I just wanted to point out is another renaming of things. So all these examples we've done so far, let's start with Yummies. In the Yummies case, we had Yummies had an equal share, 33% of purchases, or they didn't. So see how it's two options. My coin, either my coin is fair or it's not fair. Two options again. My die, I roll it. If it's fair or not fair, two options again. I keep doing this, two options of things. Now what I'm going to do is put names on this. The null hypothesis and the alternative hypothesis. These are my two options. So, just as examples to put here, my coin is fair. The alternative to that, the opposite, when we could think of that, is my coin is not fair. Okay. What was the example we were just doing? Yummies gets 33% of purchases. What was the opposite of that? Yummies does not get 33% of purchases. Right? So what do? We take the null hypothesis. That's what we build our chance model on. Right? That's the by chance alone explanation. All right? We say my coin's fair, aka 50% should get heads. Yummies is just randomly getting purchases, that's 33% of them. So we have a number here, which is nice, right? We've got a number to actually hold on to, and that's why it's an equal sign. So my null hypothesis is just what's the random chance, what's the kind of not interesting scenario. But that's always the scenario I build my chance model off of. Okay? So then the other explanation is just my alternative. Once you figured out the null, the alternative is usually pretty straightforward to do. It's just the other explanation. Now, there is something here that you have to be a little careful about. There is a choice depending on what you're interested in figuring out. I could do another one of these, this Yummies again. If I had a slightly different question, I could say Yummies gets more, let me put that underline, more than 33% of purchases. If I had some idea in my head that Yummies was the preferred candy bar, then I might be interested in trying to get evidence that they should get more than 33%. If I'm walking into this having no idea which one might be better, then I might do Yummies does not get 33%. You got to think about this a little bit. This is like your safe bet, because this includes Yummies gets more than 33%, they're better, or Yummies is worse, they get less than 33%. So you got to be a little careful about that. Read the problem, think about it. Do I have a reason to believe that my alternative should be more or less of something, or do I just have no idea, and in that case I use not equal to? Okay, so really important for you to try to, at this point, we're learning these new things, go back, connect back to what you're comfortable with. If you liked Buzz and Doris, if you liked the Yummies example, if you liked the coin, the die, hold on to your favorite one of those examples, and then take that example and everything you understood about it, and now try to apply these new terms. Because I almost said new ideas. They're not new ideas. They're the same exact ideas we've been doing. I'm just giving them names. So now the trouble is going to be, here's a problem, name everything correctly, and then do the process we've been doing for the first 2 weeks. So I have a video going through the examples that come a little bit later. So make sure you walk through those examples, check them out, try them before watching the videos, but of course just go through the videos when you get stuck.